Ahoy bringers! Welcome to your next tutorial. What we're going to do in today's tutorial is set up our collision with our item. So the first thing that we're going to do is go into the item class, and under our update method we are going to what we're going to do, set up our collision like I said. So we're actually going to cut out this code here, which was the collision for our platform, and I'm going to quickly kind of describe what we're going to do to process this collision and kind of overview what we did with the collision for the platform as well. So I'm going to open up some Photoshop action here, and when we checked for collision with our platform, what we did is we found the center of our ball, which is just position XY, and then we said, hey, we want to move down the radius, so we're getting just this one pixel at the bottom, and that's the only pixel that we're checking for collision. So when our ball moves down, this would classify as a collision. Anything within the platform would classify as a collision. But if it was just one pixel below our platform, it would not count as a collision, even though obviously it looks like they're colliding. So that's one of the problems that we had with this way of setting up our collision with our ball and our platform. It's only checking one pixel. But to get a little bit more fancy, what we can do is hide out those and open up our two items, our ball and our item here. We're going to use Pythagoras theorem to check between the collision of our ball and our two items here. So that's a great thing to remember back in the math when you're like, oh, what is this Pythagoras theorem thing? When am I ever going to use this? It's great for checking colliding balls. So that's what she said, but it's great for it. So just keep that in mind. The first thing that we're going to do is we have our two items. They're both circular, and we draw them to the screen according to the XY position, which is in the center. Each of these balls also have a radius, so we know that as well. So let's go to the next step. Whoops, supposed to hide those two. Alright. As you can see, my art skills are crazy. And so these are our two items, our two balls, and they each have a radius, of something, different. For our actual player ball, it's going to be a pixel radius of 20, and for our item ball, it's going to be a pixel radius of 10. Let's go back to this one real quick. As you can see, back to our previous example, we're going to have, if it's colliding, this line here is going to be a length of 30, because again, our radius for a larger ball is 20, the radius for a smaller ball is 10. So anywhere we move around this from the center of our larger ball to the center of our smaller ball, if they're just barely touching, it's going to be a distance of 30, right? No matter where it is. So that's what we're going to check for. We're going to use Pythagoras theorem. We're going to check the distance from this center ball to this center ball, and if it's less than 30, we know that it's going to be colliding. Hopefully that makes some sense. So let's get into a little bit of the math, where I'll go back to that other image I had up here. So no matter where a ball is, we're going to get the X and Y position of each ball. And then what we're going to do is we're going to subtract the X positioning from this ball to this ball. And that's going to give us our A right here. And then we're going to see what the Y positioning is for each ball. We're going to subtract those. And that's going to give us B right here. And then Pythagoras theorem says A squared plus B squared equals, don't look at the screen, it's wrong right now, A squared plus B squared equals C squared. So that's Pythagoras theorem. So we're going to basically find our C, and again our C, as you can see here, is the distance between the center of our larger or our player ball and the center of our item. So if our C is less than 30, then we know that the balls are colliding. Makes sense? Alright, so let's get into the coding. Enough with all the art. So let's go into our item class, and we have our check for collision here. And again, we got the information from our ball. This is the player ball. So we have ball X, ball Y, radius of that. So we're good to go there. Or we're going to set up some new ints just to keep it kind of familiar with the last little graphic I showed you. Otherwise, that would have just been pointless and just wasting your guys' time. So we're going to set A equal to be X, which is the X position of our item, minus X, or ball X, which is our player X position. Alright? And then we can set up int B is equal to Y minus our ball y position, or we'll create another int that is going to be called collide. We're going to set this equal to our ball radius, so we're going to say radius here. Whoops. We're actually going to change this right here to be ball r instead. So that's going to be our player ball radius. Again, we just set it up with this method here. So what we're going to do is we're going to say our radius of our item class plus the radius of our ball. So like I said, that will be a value of something like 30, right? So if our collide is, or if our our distance from the center of our two balls, our item ball and our player ball, is less than this collide, then we know a collision actually happened. The next thing that we have to do is we have to set up our c. So we're going to set up an int c is equal to the square root of a squared plus b squared. Because again, we have this equation here, so if we wanted to get our c, we'd have to cross out our 2 here and then just throw a square root over here, and that will be equal to our c, which is again the distance between the centers of our two balls. So we're going to set c equal to the math function, or the math class, square root, and it takes a double. So the first thing that we're going to do is set up our first variable, our a, the square root of a, and since it takes a double, we're going to pass or cast our a as a double, so this equation will work. We'll say double a and then squared plus double b squared. And that's just like for example's sake. Again, we're going to have to use the math function to call the square root of this, or we could just say a times a, right? Makes sense. Alright, so we'll take a times a within its own parentheses for, tutorial's sake, and then also our b times b. And there we go. The last thing that we're going to do is change our c to be a double as well. Whoops. Because again, this square root method is going to return a double for us, so we probably want to set up our variable as a double. So this will be the distance, if you guys want to leave a comment, distance between objects centers, something like that. So you guys can leave a note. What error are we getting now? This is stupid. Alright, so we're going to go, where did we use B before? Oh, ball. Can't use this because, again, we changed our, or we passed in a ball B. So we're going to say BB, ABB, and we're going to throw that in there instead. So, just because our ball object was also labeled B, we have to have our int object as BB. So there we go. And the next thing, lastly, what we're going to do is check for a collision. What we're going to do is we're going to say if C, again, this is the distance between the centers, is less than collide. What are we going to do? Well, we are going to perform action. And we haven't set this up yet. This will be the unique feature of, whatever. This will be like a gravity up. We'll change the gravity or whatever else. But we're just going to, create that method first. And so all of the classes that extend this item class can use their own variation of this action perform class. But all of our collisions should, work out. And just for example, to make sure it works, we're going to set x, again, the x referring to our item, x to be 0, and also our y to be 0. And we'll comment these out later, but we're just checking to see if we have some sort of a collision working. Oops. Oh, and I messed up quickly. Before we run it, also, this was supposed to be the ball's radius, not the ball x, so make sure you change that as well. Spacing out. I don't know. It's crazy. Long day, no sleep. Working hard for Santa. Just got the best of me. Alright, so there we go. We have radius plus the ball radius, which will be at like a value of 30, something like that. So let's save this, run it, and hopefully we get a collision. So let's check that out. So, whoops, missed that one. Oh, see, it's gone, guys. So it looks like that worked, and we are actually, it's a better collision detection than, like I said, the square example, because for the square example we were just checking for 1 pixel, whereas this is checking for pretty much the collision spot on, because that works. And again, that works because they're balls, and Pythagorean theorem is just great with balls. So I'll catch you guys later, and have a good one. Something called Pythagorean. I'm going to use something called Pythagorean's theorem. Is that right?
Close enough.
We're going to use some math.